We've been looking at the periodic trends the last couple of days. So we're going to talk about those trends in more detail today. Also, we're going to talk about a couple other trends that you haven't looked at yet. So we've looked at 3 out of the 5 trends that we are going to focus on. The first trend that we're going to talk about is chemical reactivity. Alright, so chemical reactivity is simply the degree at which an element can react in compounds. Chemical reactivity is different depending on whether or not your element is a metal or a non-metal. Alright, and so we've already gone through the periodic table, so you know what the metals are and what the non-metals are. Alright, which, by the way, that's what your quiz is on tomorrow, is the periodic table. Metals, non-metals, metalloids, the names of the families, and those oxidation and valence electron numbers that are on it that you labeled. So, in other words, your quiz is on this sheet tomorrow. Alright, so let's talk about if your element is a metal. Alright, so if your element is a metal, the closer to francium, the more reactive. So when we were talking about families on the periodic table the other day, I told you that the alkali metals were the most reactive metal family. So that's column 1 on the periodic table, the alkali metals. So francium is at the bottom of that, and so therefore it is the most reactive of all the metals that we have. Now, if there are 2 metals equal distances away from francium, you're going to always go with the element that is further left. Alright, so let's look at some examples of how this might work. Let's say we wanted to know which element was the most reactive, and I was given calcium or nickel. So we would look these up on the periodic table. Nobody needs an iPad out. And we would be comparing calcium and nickel to francium. So which one is closer to francium? Okay, so it is calcium. So if we're looking at the periodic table, here's francium, here's calcium, and nickel is right here, right? So if we're comparing those to one another, calcium is definitely closer to francium, so it would be more reactive than nickel. All right, what if we had cesium or radium? All right, so if we're looking at these two, they're found where? The side and on top. So they're equal distances away from francium, so the rule is what? Go further left, which would make it what? Cesium. So cesium would be our most reactive. Alright, so this is if we're dealing with a metal. So we have a different rule if we're dealing with a non-metal. So for a non-metal, the closer to fluorine, the more reactive. And if you remember when we were doing the periodic table, I told you that the halogens were the most reactive non-metal family. So the halogens is fluorine's family. Fluorine is at the top of that family. It is the most reactive of all non-metals. Now, there's a disclaimer with this one as well. If two non-metals are equal distances from fluorine, you're going to go with the element further right. Unless it's a noble gas. The reason why? The noble gas family is the least reactive family out of all of the nonmetals. So in other words, if we were comparing nitrogen and argon, all right, here's nitrogen and here's argon. So they're each only one away, or two away, depending on how you're counting it, from fluorine. So our rule would say we go with the one further right, but the one further right is argon, and since argon is a noble gas, which is this family right here, it cannot be the most reactive because the noble gases are the least reactive. So then we have to choose nitrogen instead. So let's look at a couple examples of these. Again, we're going to choose the most reactive. And let's say we have nitrogen or chlorine. which one is most reactive?
Chlorine.
It would be chlorine. Chlorine is closer to fluorine, so it would be more reactive. All right, how about if we had oxygen or neon?
Oxygen.
It would be oxygen because neon is a noble gas. All right, so that's how we do chemical reactivity. If it's a metal, we're going to compare it to francium. If it's a non-metal, we're going to compare it to fluorine. So we're looking at the F's in opposite corners of our periodic table. All right, our second trend that we're going to talk about is one that you guys looked at